not by hand. Okay, you do it by manual. Okay, how to do that? Let's see. Okay, for this, you first do integration with respect to x. Okay, so I didn't do by hand. Okay, so yeah, how to obtain this? Yeah, you have to do integration. What's the formula there? Type your matrix. If this is your BTDB, okay, you do your integration. With respect to x from 0 to L. Okay, this is how I obtain the expression below. Okay, this is how I obtain this. Then next, you do the integration with respect to y. So make sure you have already integrated. You integrate with respect to y from So finally, you obtain this 4x4 matrix. Okay. And how about the solution for that? Yes, please proceed with the solution. Yeah, the solution is this. Okay. So this is not solved by hand. Okay. Good news for you. This is the knowledge. We only test you up to the constant strain element. But for your knowledge, yeah, this is what you obtain. Okay. So finite element is only valid in the time when computer is invented. Okay, it is not solvable by hand. Okay, so only with the invention of finite computer, then you can solve it. Okay, so yeah, and then next we come to your homework questions. Okay, for your homework, yeah, you only have 2 questions. Okay, this is the point I want to highlight. Okay, you might not handle this distributed force before, okay? But in the presence of distributed force, you need to do proper interpolation. Okay, let's see. Okay, linear force distribution along line 2, 3. How do you do that? Okay, remember the equivalent force is obtained by work done. Okay, so this work done on line 2, 3. Okay, yeah, must be a line integral. Okay, the line change from okay, this is dy, let's say, okay, from some height to another, and then the force, okay, the work done by horizontal force must be horizontal displacement and horizontal force. The work done by vertical force must be vertical force and vertical displacement. Okay, and then now you can do the split up. How do we interpolate the force? Is the force constant? If it's constant, then just do the integration straight away. We go straight to the straight function. Okay. So in that way, when you do the partial differentiation of the work done by the external force, okay, you see you have the u1 shape function 2 times tx, v2 shape function 2 times t1. Okay, you can see that u2 and tx, v2 and t1. Okay, they are in the same direction, so you have a non-zero product. Then u3 times tx, v3 times t1. But the integration got to be done by the shape function along the line. Okay. 好，所以看一下这样的这个形状函数。So the shape function can be obtained from our previous derivation. Okay, in this case, I'm using the geometry method. How do we find the shape function on line 2, 3? Okay, this is shape function what we call N1. Okay, it is vertical line. Okay, it is 0. No, it is 1 and x equal to 0. It is equal to 0 along line 2, 3. Okay. So this is a shape function 1. Okay. And then next, how about shape function 2? Shape function 2 is based on the opposite line. Okay, this can be expressed as x over a equal to y over b. But you now do the difference, and that's a shape function. N2 is 1 when x equal to a, and then n equal to 0. And then lastly, you might talk about shape function 3. Shape function 3 is the one opposite. Okay? This is y over l. And then next question is, what is the shape function along line 2, 3? Okay? It is 0 for shape function 1. And then it is non-zero for shape function 2. It is also non-zero for shape function 3. 所以你看，你就是从节点2到节点3，沿着这条线走，对于形状函数1，它都是0；但是对于形状函数2，它是会随高度的变化；对于形状函数3，它也是会随高度变化。所以这个就是一个代入过后，形状函数在2、3这个垂直线上的一个变化。So the shape function along the line 2, 3 are non-zero for shape function 2 and 3. Okay. Then next, when you are doing integrating the force along the x directions on knot 2, then you have to bring in what is the shape function N2 times tx. And how does the t change? Okay, the tx. Okay, tx here you see, they are all tx. They are changing from 0 at height 0 to full value t0 on height equal to L. Okay? So this tx can be expressed as p0 y over L. Okay? So if you do the integration, then you have one value. Okay? So likewise, you can do because there are no distributed force in the y direction. So the T2, F2y is 0. Likewise, F3y is 0. The only non-zero force is horizontal force of knot 3 next. Okay, that is 1/3. Okay. 所以你看到你的水平力 F2x 跟 F3x， 那你算的对不对？做法很简单，把这两个力加总，它是多少？1/6加1/3，就等于1/2。这个两个力加总是不是等于这个分布力的面积？分布力基本上就是 P0乘上 L 除以2嘛。所以你的那两个个别节点的力加总在一起， 一定要等于你图上面看到的这个总的力。So in this way, you are able to find out the normal force. Then likewise, please proceed to find out what is your stiffness matrix. Okay, and then next question 2. Yeah, for distributed force, it's not easy either. Okay, in this case, this is a numerical example. Then MATLAB can do a good job for that. And then how do you find out the MATLAB answer using my previous script? Please go back to your MATLAB script. If you need to solve for value, okay, symbolic calculations won't give you any value. But if you want to solve for value, you may have done the symbolic calculation before. And if you want to input the number, put in the number, and then evaluate the symbolic expressions with the number. So you have to put in the evaluate. Okay? So inverse of stiffness matrix times force will give you the symbolic expressions of displacement vector. But if you want to suck in this value into the symbolic calculation, please type the command evaluate. Okay? So please go back. I think this should be with you, right? In the E3. Okay? So let me check that if you have that on E3. Okay, the script is there inside your ANSYS. Inside ANSYS. Okay. Yeah, you have the script here. So this will give you the this. Yeah, please go back and try out. Okay, don't waste the good tools. And you can use the tools. So in this case, the problem here is how do you find the force on along this? Okay, we'll see element 2. This is 1, 3, 2. Okay, the expression you do the substitution there is there. You can find out the stress as we did before by number. Okay? But this one, please go back to use your previous function. Okay? Look, why I'm saying this is, look at here, the integration expression. When you are searching out for the force, even if it is a constant force, your integration of the shape functions, yeah, will it be equal? Okay, yeah, it depends how the shape function look like. Okay, yeah. So let's say you want to integrate shape function n1 with respect to the height, or n2 with respect to the height. You see, this is n1 and n2 and 3. So if you do that, okay, n1, n2, and 3. So if you do that, okay, integration of ay divided by 2a with respect to y. Okay, the good thing here is half. Okay, it makes sense. Right? And that's it for the homework part. Please go back and practice. Okay, this part, yeah, could be more demanding for multiple variable handling. Yeah, make sure you can do these two examples pretty well. Okay, in the previous year, most of the problem with your senior is they have the tools, but they don't know how to use it. And they have the tools, they have the answer, but they did not write the working step. Make sure you have the working step, because up to this stage is hard. I cannot expect you to have the complete answer, but you must make sure you give me the step. I'm marking based on the step, your working procedure. Okay, if your step is right, then you got the mark. Okay, even though the final answer might not be completely correct. Okay, yeah. So I think that's it. Any questions so far? Okay. Yeah. So yeah, that's good news for you. You are handling 2 or 3 degree of freedom in the final examination. But the starting matrix is in 6 by 6. Okay? And multiple. Okay. Oh. So no question, and that's it for today. And then yeah, good luck for your final examination next week. Yeah, 3 hours and 4 questions. 2 beam element and 2 constant strength triangular element question. 好，好，谢谢大家。